Welcome to the Futurati podcast. Any member of the Futurati is somebody who believes in the power of the future. We know there's a better world ahead, and we indeed have the power to make it so. In our podcast, we talk to the best minds in the world about the most urgent problems facing mankind today, and we hope you learn as much from them as we do. I'm Thomas Fry, a professional futurist and keynote speaker.
And I'm Trent Fowler, a machine learning engineer and author. Thank you for joining us. All right, hello everyone. Today we are joined by Brian Enke. Brian, thank you very much for being here with us.
Pleasure to be here.
Now, you have got a resume that just goes on forever, so I thought I'd give you the floor, and please feel free to tell us everything that you want to about your background and what brought you here.
Yes, thank you. The resume has extended for a while. I guess it would start in the mid-'80s when I worked as a software engineer in the systems integration group at Bell Labs. That part is relevant to some of the later things because we really dealt with complexity there, and complexity is one of the biggest problems that we face in society today. If we talk about futurism and creating the future, we always have to deal with complexity. We always run into it. So that took me through about 2001 when I hopped over to the Southwest Research Institute. So there I am a space research analyst. That's my current position. So for about 20 years, we've been doing space research that touches pretty much every planet in the solar system. We deal with moons, asteroids, comets, all of the good stuff out there. And there's a lot of good stuff out there. People view space as being kind of empty, but it's really not. It's full. So for the last 20 years, a lot of space research. I'm currently the chief science pipeline engineer for the New Horizons mission, which is the spacecraft that flew past Pluto and Kuiper Belt Object Arrokoth last year. We're about 7 billion kilometers away from Earth, and I run the science pipeline, basically, on the engineering side. So we get all the data back from the spacecraft and make it make sense.
Well, that's fascinating. So I do want to get back to the transition from Bell Labs to the Southwest Institute, because that's an awful big jump there. But first, I wanted to lob you a softball to get started here, and feel free to riff on this as much as you want to. So what is it that draws you to the high frontier? So what are the economic and philosophical reasons that you want to see a human presence in space?
Ooh, a big question. And yeah, when you talk about philosophy, I love to talk about philosophy because another part of my resume is that I'm a science fiction author. And so when you're writing science fiction, you try to imagine futures. And philosophy comes with the territory because there's, of course, an infinite number of futures and an infinite number of ways to get there. But some are much more desirable than others. So now, bringing back my science fiction writing together with my engineering, when you're creating the future, you have to be careful. So there are a lot of ways to go wrong. And so you ask what draws me to space. I see space as this endless fountain of opportunity. It's hard to imagine a future that does not involve space. I think that's how I would phrase it. Especially, again, think of the future in terms of a science fiction author. You have a lot of dystopian authors who write about life here on Earth. If we don't go into space, something usually goes wrong, like a nuclear war or famine or whatever. And it's a very dark future. All of the really positive futures tend to involve space. I'm having trouble thinking of any that don't. So maybe that's a simple way to describe it.
Yeah, I'm inclined to agree. It's hard to imagine a scenario in which 1,000 years in the future, humans are flourishing, but we're not in space. It's difficult to imagine what pathway we would take in order to get there.
Exactly. I have a lot of trouble with that. there just aren't many. There are too many problems along the way, too many ways that society can derail itself along the way. If you're out into space, then almost by default you have to set up many branches of society. And these branches of society are going to have some form of independence from each other. So some of them will fail, some of them will succeed. That's the only way you're going to generate a sustainable future, in my opinion.
So Brian, what we see a lot of science fiction on television. We're all kind of drawn to believe that there's going to be other aliens out there. Except when you really think about it, if there's aliens on another planet, they're raised with different gravitational pull. They're raised in a different atmosphere. They're raised with different food sources, food stocks, and so they have different predators. They have different dangers on these planets, and so the reality is that there's the likelihood of them looking anything like humans is very remote. Can you speak to that a little bit? Because I think this is such a false assumption that we have right now.
I think it's a false assumption in the science fiction world for some sci-fi, but not for others. There are examples of exactly what you were saying, where it's more of a diverse future in terms of aliens that are encountered. Basically, I agree with what you just said. We really have no idea of what's waiting for us out in space when we go farther out. We have a pretty good understanding of our solar system, and even within our solar system, we have found environments that are similar to Earth-like, but different in many important ways, like you mentioned, gravity, atmosphere. And then we found environments that are totally alien to us. And so imagining life forms that thrive in those environments, they would be nothing at all like us. There's some assumptions that people like to make when they think about future alien life forms, like are they carbon-based? Some people like to speculate about silicon-based life forms or some other basic element that composes the matrix of life. Could be very different. Could be very different. It's all fertile ground for science fiction authors.
Right. Now, if we're the odds of us going into space within the next decade here, landing on another planet are, I think, fairly high. There's a lot of arguments about whether we'd get to the moon first or get to Mars first, and which country actually accomplishes it. I know you've got a lot of thoughts on how things are going to progress. I find the efforts from India particularly interesting because they're certainly the underdog, but they have some awfully bright people and some strong desires to make things happen, to make themselves look good. So would you like to talk through some of your thinking on this area?
Absolutely. And in fact, to build on what you said, India is indeed a very exciting place right now. They have a lot of cultural and societal issues to work through, and you hear some of the arguments that they go through. They're very similar to what we hear all the time over here. It's like, oh, well, the space budget is too high and it could be spent to solve this and that problem or whatever. So they go through all that too, but yet they are also doing a Mars mission right now. The United Arab Emirates are another place that they're doing a Mars mission. Israel, all kinds of good things are happening there with simulated Mars missions and with space research. Canada is not typically a powerhouse of space exploration, yet they make several critical components for the International Space Station. And there's a lot of interest that they might do more in the future. The list goes on and on. Japan. They have done a mission, actually 2 missions now, to return samples from an asteroid. That's cutting edge. That's an amazing contribution to planetary science and to the future of space exploration.
So I don't really know that much about these different missions and how coordinated they are and what the internals are like. Do you know enough about them to speak a little bit on the subject? I mean, is Israel coordinating with Japan? Are these all just different isolated efforts? Are they talking to each other? What's that like?
That's a great question. I don't know enough about the nuts and bolts to actually get very deep into it, but I could say maybe a word or two about the big picture. There is a lot of cooperation going on. Some of it is just in terrestrial terms, internet-based research, the type of things that we see every day, because remote collaborations are much simpler than they used to be. So really, to some extent, it doesn't matter what country you're in order to do the actual work, other than you get into politics, i.e. the structure of countries that we have, and certain export restrictions, restrictions on technologies that can be transferred, things like that. So that's maybe the counterforce to this cooperation that's going on. There are some impediments to that. But yes, a lot of cooperation. I think it bodes well for the future as well. It's going to be interesting seeing what happens with China in particular. That's a big topic right there. And it's hard to tell what direction we're going to go. It could be that things are going to open up a lot more with regards to China. The big problem with China is, of course, that the Chinese military funds and derives technology benefits from the space program to a larger extent than anywhere else in the world. And so that's a difficult obstacle for cooperation. It's hard to share technologies with the Chinese Space Agency without worrying about them ending up in some sort of military application. So there are concerns like that. But the future's bright, and there will be a lot of cooperation between countries.
So you said that the United Arab Emirates has a Mars program, is that right?
Yes, they just launched actually, I'm not sure if it launched yet, but they were about to launch a Mars, I believe it's an orbiter, and it's going to study the atmosphere of Mars.
Okay, and then Japan as well?
Japan hasn't done too much with Mars, but they have done several very exciting asteroid missions.
And then you said something about Israel. Do they have a Mars mission?
Yes. Israel is more doing research. That would be a lot of what they're working on is focused on future human exploration of Mars. Not sure if they're doing much with the moon. I naturally talk about Mars because that's where my interests tend to be, and there's this moon versus Mars issue that's out there forever, and I don't get very excited about it because I'd be happy with either one, and most people are that way, I think. But in terms of the research, you kind of split into different camps. You have lunar research and Mars research in a lot of ways. There's not a whole lot of overlap, and it's partly because, as Thomas was saying, the environments are so different. We were talking back then about aliens or aliens that would evolve on these different sort of bodies, Mars versus the moon, for example. But you have to remember that we humans are aliens when it comes to either Mars or the moon. The environments are so different that being able to live on them is going to require much different technologies and different strategies.
So once we move to Mars, we're going to start a Mars colony there. What's the food source? How long does it take before we start growing our own food on Mars?
A lot of assumptions built into that question because it depends on how many people you send and what they're able to bring with them. Food is a really good topic to speculate about, though. Basically, food production can begin almost from day one because you don't even need to research Martian soil really in order to grow food on Mars. You could use hydroponics. You could have energy sources that are completely self-contained, i.e. LED lighting and heat sources that are local. Basically all the things that crops need to grow. The problem is always scaling up, because if you get 10 people on Mars, they can live with local food sources. If you get 1,000 people on Mars, you need organized agriculture. And that's a pretty big leap. Fortunately, the surface of Mars is accessible, I'll say. Again, we'll go back to these differences between the Moon and Mars. On the surface of Mars, you could grow some crops if you have simple greenhouses. You basically just need to up your air pressure in a greenhouse, and you can grow things on Mars. On the Moon, not so much. The radiation environment is much harsher on the Moon. So, yeah, in terms of a larger Martian settlement with organized agriculture, very hard to do. And I think that'll be a long time into the future.
So going to Mars, there are certain windows of opportunity to send a rocket up there. Can you talk a little bit about that? Some years are just not good years to go there.
Yeah, why is that? I mean, what are the dynamics at play there?
It's basically because the planets are always moving relative to each other. The orbits are somewhat elliptical. They're not perfectly circular. You look at the details of those orbits, they are very small in terms of the inner planets. They're much larger, more pronounced when you get to the outer solar system. For the inner solar system, orbits are fairly circular. However, almost is not the same as exact. It makes enough of a difference to where in certain years and at certain points of time, it's easier to launch from one planet to another than it is at other times. The biggest problem with that too, of course, is that at each point in time, a planet is in a certain place within its orbit. So relative to each other planet, you're trying to think of the right word. I'm thinking conjunctions. But that gets into a little bit of a different direction. It's basically the alignments are different. We have a good opportunity to study this coming up, because over the next couple of months, Mars and Earth are actually going to be pretty close together. So if you launch a mission from Earth to Mars, when do you do it? Do you do it when the planets are closest together? No, you actually have to do it in terms of, if you want to use the minimum amount of energy, you launch earlier, so that when you reach Mars, the planets are closest together. Orbital mechanics is a very fun field.
So just
NASA has. Oh, go ahead.
Yeah, just in rough terms, let's say I launched the rocket at midnight, 12:01 midnight, and I set my stopwatch. How long is it going to take me to get to Mars?
The biggest question there is what type of rocket it is. If it is a conventional chemical rocket, like we use for almost everything right now, it's going to take you, well, you have a choice. You can get there a little bit faster and burn more energy, or a little bit slower and burn less energy. So anyway, the basic question is 6 months on a faster trajectory and 9 months on a slower one. Now, certain orbital alignments are better. You could actually do 4 months on a fast trajectory, but people usually assume 6 months. Now, if you're using a nuclear rocket, which doesn't exist yet, unfortunately, NASA has been working on them forever. The Russians have been working on them forever. It's always right around the corner. Nuclear rockets, in theory, could get you to Mars within about 1 month.
Wow.
So the transit times can be much faster than they are with conventional rockets. However, of course, there are trade-offs. You don't get something for nothing. With nuclear rockets, you have to shield your reactor from any human crew that's going along or any other perishables that could be affected by radiation. You also have higher thrust, so your profile of the mission is very different than if you're doing a chemical rocket. For a chemical rocket, you have a whole lot of thrust right at the start. You basically launch from Earth with a lot of thrust, and then you coast the whole way to where you're going, say Mars. With a nuclear rocket, you thrust for about half of the trip, and then you turn the spacecraft around and decelerate for half the trip. Okay, that sounds great. It cuts your travel time extensively, but now you have a problem. What happens if you turn your ship around and you blow a gasket and you can't slow down? You're going to be...
You're a missile.
Hurt. You missed. Yeah, you missed. Well, that's not a very happy thing. So diving into the whole orbital mechanics question in more detail, there are these things that are called free return trajectories. It's basically alignments within alignments such that if you're using, say, a conventional rocket, you can launch toward Mars, but if something goes wrong, you can abort and loop around the sun and come back to Earth maybe in 2 years, say. So you're not totally lost in space if you have an equipment failure. Lots of trade-offs, lots of engineering, but it's fairly well understood now. We understand how to do this stuff within the inner solar system. So that's mature.
So will Elon Musk actually make it to Mars?
Great question. I would say if he doesn't make it to Mars, it won't be because of any technological reason. So let me answer it that way. When you look at a space mission and what he's trying to do, some of your issues are technological and other issues are different, legal, political, societal, things like that. They actually tend to be more question marks. The technology that he's using and the plan that he has, you can find small optimizations. Bob Zubrin likes to improve his plans. I'm not sure how well received that is. I hope it's very well, because I think the intent is to help. But, it's really not a technological problem now. Elon Musk, if he keeps doing what he's doing, he's launching his rockets, they're getting bigger and bigger. He's learning about how to keep people alive on his rockets. He just launched 2 humans last month to the International Space Station. He is on a path to solve every major known engineering problem with a Mars mission, and I think he'll get there very quickly. The other problems are harder.
Right.
It can be harder.
So let's get into that. You told me privately that you don't think money is the biggest obstacle to the human expansion into space, and you've just said that you think that Elon Musk is on a pathway to solving most of the major engineering problems. So can we talk a little bit more about what it is that stands in the way of us accomplishing that?
Many things stand in the way, and yes, I do think that money is not the biggest of them, at least not for Mars. It is a big problem for certain other things that we'd like to do in space. For Mars, if you have an attitude like Musk, where he's basically doing settlement-oriented missions, he doesn't need a critical cash cow application on Mars. He doesn't have to, he's got more leeway with the economics. So money is not as big of a problem with him. But there's other things. Let's talk about legal issues. That's a big one, actually. We actually need lawyers in space. There's not much space law in existence right now. And what we do have is based on the law of the seas, which is a couple hundred years old probably, and applies only to oceans on the Earth. Things like cooperation between other countries are very vaguely defined in terms of space law. Space law that exists today is there's certain lunar law that was established back in the 1960s. So we can do certain things on the moon and we can't do other things if you're a country. Well, what about if you're not a country? What if you're Elon Musk? You are a person and a corporation. What laws pertain to you? Do you have property rights in space? If you send something valuable up there like people in a habitat, can somebody come along and take them away from you? Can they secede themselves? If you get settlers up there and they say, well, we don't like Earth, let's just be our own planet. What's the legal foundations there?
This brings up
all kinds of questions.
Yeah, this brings up this question that I've been speculating on this for a while, that as soon as we get as few as 8 people on Mars, we're going to have the first person that declares themselves president of Mars. That they're a self-governing planet, and they're not subject to any of the laws of Earth, which I don't think they should be anyway, but that's a whole nother issue.
Well, are you familiar with Kim Stanley Robinson's Mars trilogy, Red, Green, and Blue Mars?
Yes.
So one of the very first issues that he tackles in that series, which is just fantastic, is the fact that once you're out on Mars, there's just only so much Earth can do. I mean, they can send ships for you, they can send troops maybe, but it's a long way out there, and there's a lot you can do before they get there. And if you've got a year or two on them, you know the terrain better, and there's all these entertaining little vignettes in the books where they thwart the UN's attempts to stop them from doing various things. But yeah, it's an important question, but I think ultimately it's going to be a little like trying to control the American colonies or control California during the gold rush. It's just, what are you going to do? Send an army through space? It's going to be quite difficult to enforce any rules that we make here.
Yes, complete agreement here. Stepping back a second, we were starting to talk about some space missions and ways to get to Mars and things like that. And if you look at it more historically, there has been 2 sorts of Mars mission plans up to date. One by NASA, it's sort of an Apollo on steroids sort of mission that would get your people there. Second generation of Mars mission plans was Mars Direct by Bob Zubrin. So you live off the land. You are a much more self-sustaining sort of a mission. Generation 3 missions, which I predicted back in Shadows of Medusa, kind of as predicting sci-fi-like, but they're pretty much in reality almost now. It's basically what Elon Musk is doing. He's taking Mars for Less, Mars Direct. Mars for Less is a different plan, sorry. Mars Direct, there are many Mars plans, many. But Mars Direct is a staple. And Elon Musk, what he's doing is basically mass producing Mars Direct and taking a settlement first. But then I've also speculated about Generation 4 missions. So what would a 4th generation mission look like? And what I'm thinking there is that basically a 4th generation Mars mission is determined and created by the Martians themselves. It's exactly what you're saying with Kim Stanley Robinson. Once you get people on the surface of Mars and they've been there for a while, they know the environment, they are going to have very little reason to go out of their way to do much with these people back on Earth, other than economically, perhaps. There will be some trade, hopefully. But at some point in the future, they are going to be their own branch of humanity. In fact, they may be many branches of humanity. A Mars settlement, in Kim Stanley Robinson's terms, he had his red Martians who like to keep the planet untouched in pristine condition, as opposed to his green Martians who wanted to terraform the planet. Well, if you're a red Martian, you could build thousands of independent biomes. You could have thousands of independent branches of humanity, basically, on the surface of Mars with very little interaction. That's pretty exciting, I think. that's a very exciting future to be writing about and speculating about. What's possible when we have thousands of branches of humanity? It changes everything.
Yeah, I completely agree. So one thing I wanted to circle back to is that I feel like you've painted a very compelling picture for expanding into space, but it sure seems like there are many problems here on Earth that remain to be solved. So what is your basic elevator pitch for diverting resources into settling Mars or settling the moon as opposed to putting everything we have on poverty or climate change or some of the things that plague us today?
I have two of them, actually. So the first one is more of a joke, and it's basically just asking people, okay, so let's apply this back to 1492, and Christopher Columbus is looking over there at Queen Isabella and saying, please give me all this money to go out and explore. So you can just kind of ask someone, well, what if she had said no? What a utopia Spain would be right now if she had just not given those funds to Columbus. And of course, that makes no sense at all. Money spent on exploration and expanding our horizons and our understanding and our knowledge is always paid off many, many, many times over. So Spain would probably be in much worse shape today. Even though they were going through a civil war at the time, it was really bad happenings over there in 1492. They had many other places that they could have spent that money rather than funding Christopher Columbus on his crazy expedition. So that's kind of the fun one that I like to say. But and in fact, let's just leave it at that because I think that's actually the best way to look at it too. We get so tied up in our problems here. In the here and now, but a very wise man on his website at least proposed the idea of the future creating the present, and so you probably know who I'm talking about. That's movie Tom. And I think you are absolutely right. The future creates the present. So what is the future that you're working toward? Sure, you can throw an endless amount of money into problems here on Earth. Let's take climate change. I like to speculate about climate change. You could throw endless amounts of money at climate change, and maybe the one best breakthrough for climate change involves something that is possible out in space. I think that's not a far stretch at all. So if you had killed your space program, say, and thrown an infinite amount of money at climate change, you might fail. Whereas if you just throw a little bit of money into space exploration and development, you might succeed in solving that problem as well. We don't know. We don't know what the solutions are. We barely know what the problems are. So it's just very self-limiting to paint yourself in a box by spending without any regard to the future, basically. You need to keep your options open.
Yeah, I completely agree. So where do you think are the easiest and safest places for us to settle in space? So you said you would be happy with a Mars colony or a moon colony. Can we talk a little bit about the trade-offs there? I mean, just as a layperson, the moon's a lot closer. I mean, wouldn't that be easier? I take it that your answer is probably no. So can we talk a little bit about settling in space and what that looks like in terms of the problems that have to be overcome?
Yes, that's great. Let's talk about that for a second as Moon versus Mars. Now, there are a couple of other options, but Moon versus Mars is a good place to start. So the moon is closer, as you said. It is also much more difficult to live there, in particular if you want a large number of people living there. So if your goal is to build a science outpost, the moon is probably a very good spot to do it. The location benefits are going to be far more important than the other benefits that Mars might have. If your goal is to set up these different branches of humanity, these 1,000 biomes that Kim Stanley Robinson's Red Mars people might get into. Very hard to do that on the moon. On the moon, your people are going to need to live far underground. There's no atmosphere to block radiation. There are very few resources on the moon in terms of the CHONS resources: carbon, hydrogen, oxygen, nitrogen, and sulfur. These are the constituents of life. Carbon is a big one. The insider space joke with carbon is that if you send people to the moon and they poop all over the place, their poop is going to be worth more than gold. And they're almost correct. It would cost more to send that carbon in useful forms from the Earth to the moon than if it were made of gold.
Wow.
Yeah, it might be stretching it a little bit. But basically, the problem is carbon. The moon is carbon poor. Carbon is very useful for growing things and people, crops and people. So, yes, very difficult living on the moon. Another fun little thought process that I like to tell people is, since I live out here in Colorado, I can look out my window and I can see the top of Long's Peak. It's one of the 14,000 foot peaks out in Colorado, and that's great. So the question, would you rather live on the top of Long's Peak, which is close enough to be seen by us here, or would you rather live in Fiji, which is far, far away? It takes much longer to get there, much more energy to get there. You have to plan your getting there in much greater detail. And once you're there, it's harder to get back. So all of the disadvantages that Mars has. However, living on the top of Long's Peak would be very hard compared to living on a beach in Fiji. So there you go. That's the answer in a nutshell. I think Mars is the best place in the solar system for humans to live other than Earth, because it is very Earth-like compared to everything else that we've found.
Can you talk a little bit about what it is that Elon Musk has that does he put something different in his Wheaties every morning that he eats that makes him have more drive and passion about getting into space than most people? Or what does he do different than people in the past?
I think he does put something different in his Wheaties, and we need to learn about that and get more people doing that, because he's a visionary. I think that's the quick answer to your question, and you know this better than anyone. His time frame, he's not looking at today, he's looking at tomorrow, and he's solving problems that don't even exist yet today. And that's what motivates him, I would assume. Yeah, he wakes up every morning and he's thinking thoughts of the future. And it has to be very exciting for him, but the little bit that I've done of that has been very frustrating too, because we live here in the present and there are all these things holding us back. So I imagine he is a very frustrated person as well.
Yeah, no doubt about that. So that's actually a pretty good jumping off point to what I think will be the second part of this conversation. And you mentioned that he's a visionary, and that's true. And I know he grew up on a steady diet of science fiction, which he's talked about as well. So you write science fiction in your spare time. I was wondering if you could comment on your motivations for doing that and maybe say a few things about the place of science fiction in directing future scientists and future scientific endeavors. There's this kind of back and forth and interplay between engineering and the sort of fantastical visions of tomorrow that you find in works like Kim Stanley Robinson's.
Yes. In fact, I think your lead into that was a very good description of why I got into it. Because I was motivated by science fiction in my younger years. There is this feedback mechanism. You have to have the vision before you get the motivation. People, as they live their daily lives, they're going to be more successful and throw more energy into things that really excite them. And having a strong and positive vision of the future is very exciting. It gives you something to work toward. And in terms of my own writing, I initially got into it because I had more technical reasons, and they're kind of spelled out in the afterword of the book. It's basically, I thought that there was a better way to be thinking about things. And in terms of what that is, basically, let's not get into that because Elon Musk is doing it. We'll just say, it's basically everything that he's doing. He's created this vision of the future where it's possible for people to live on another planet and to be a separate branch of humanity. How exciting is that? That is incredibly exciting. In fact, if that doesn't excite someone, I don't know what would.
Such a person might not be reachable.
Yeah, and education, the edutainment is the word you hear a lot. You've probably heard this in other contexts as well.
Yes.
But edutainment I take very seriously. I've also been a robotics mentor for a high school team here in Colorado for 15 years now. Edutainment is the word there because you build these robots and they compete and you have a lot of fun, but the main point is that the kids are learning about science and engineering along the way. That's what I think good science fiction is. I'm a hard science fiction writer too, so I don't write as much about aliens, although maybe that'll change in the future. I'm not giving anything away. And I don't write about unicorns and dragons and things like that, which sometimes get lumped together with science fiction. And I write harder science fiction, which is focused on engineering and, real future world possibilities.
Plausible futures. Yeah.
Plausible futures. Thank you.
Yeah, Brian, can you expand a little bit on kind of this halfway point, which is the idea of space tourism, space hotels, people getting a taste of going into space, feeling what the weightless conditions are like. How do you see that as the preamble for going to making a trip to Mars?
The space tourism market is very fascinating to dive into because it happens to be one of the near future markets. People have talked about perhaps building hotels in orbit around Earth. They run into problems with resources because you basically have to launch everything that you need off of Earth and have a steady flow of people going both ways, things like that. So yeah, it's a little harder than it sounds, but the market could be huge. And you look in terms of the real world economics that we live in today, tourism is a huge industry. People are willing to spend large amounts of money to go climb Mount Everest, for example. Adventure tourism is huge. We'll see what happens with all of our COVID things going on. They could change a little bit. But yes, tourism is perhaps one of the gateways that will start to open up space to development.
Yeah, one of the questions I've always had is, if I booked a week at a space hotel, the first day is very cool. It's like kind of this gee whiz factor, getting to look out at all the planets. But then suddenly I get bored. There's no golf course out there. There's no swimming pool. So what the hell do I do for the remainder of the week then? Excellent
question. And I will turn it right back to you because you said there's no swimming pool, there's no golf course. Well, why not? Should there be? The way I'd answer your question there is by pointing out that even on the Earth, hotels have always been centers of commerce. Where you build a hotel, your economy tends to thrive because they enable so much more. Now, for the person staying at the hotel, they can have a lot of different motivations. They could be a business traveler, so their pursuits in orbit are not going to be more adventure-oriented, entertainment-oriented. But for the rest of us, I love to travel. My wife loves to travel. We're going on a golf trip next week. So yes, I want to golf in space. That would be amazing. I want to have the swimming pool in space. I want to have the zero-G basketball court. You can go on and on. When you think about sports in space, and other entertainment options, which maybe we shouldn't get into. There's the Mile High Club.
Yeah, the Super Mile High Club.
There will probably be a market aimed at that. I think we have to get creative, and we have to realize too that we don't have an orbital hotel yet. And once we do, all of a sudden somebody's going to come up with ideas, and everyone else is going to be like me and you on this call thinking, oh, why didn't I think about that? It's going to be obvious.
Yeah, great answer.
However, you do raise a good point. The first day of looking at Earth, it's going to be amazing, but it will get old pretty fast. You got to have more.
Okay. Yeah, that's a great way of describing all those options there. Now, what's the main hold up in getting a space hotel? I mean, we've got the International Space Station. Something similar to that would seem like relatively easy to create. Why not go with something like that?
I think the main reason is that you have a lot of logistics with a hotel. You have people that are working in hotels. In the future, you could maybe send something up into orbit that's completely automated, but it'd be a little bit difficult too. You might want staff on hand to deal with any issues that come up, and there will be some, I'm sure. So basically look at a hotel on Earth and look at all the logistics, all the army of people that actually make that hotel work. I like doing this when we travel. I mentioned my wife and I, we love to travel, and we like the occasional trip to Hawaii. So we'll stay in a big hotel resort in Hawaii, and I like to just look around and look at all the people that are working and doing things there. You need equivalents out in space, and that's difficult. You also need a lot of food. People need to eat while they're there. We talked earlier about it's a little bit difficult growing crops in space, especially if you're in low Earth orbit where you have no soil. You may have some water. Water is heavy, so that's a lot of mass to be lifting from Earth. You may have energy, depending on what orbit you're in. You have probably quick day-night cycles, things like that. So it's going to be hard to grow your own food. I think that's the assumption. So that means you have to bring all your food with you from Earth. Again, more logistics, both in space and on Earth. It's harder than it sounds. However, there are many companies that are thinking about this. There have been plans developed. I can think of two in particular that got far enough along where they were looking for venture capitalists to get involved and actually start building stuff. And they weren't able to get past that point, I think. To make an argument for a venture capitalist, it's difficult right now because no one has done it yet. You mentioned ISS. That's a good example. We can draw a lot of learning from there. Bob Bigelow wants to get into building hotels in space, and he has inflatable structures in mind that he's going to be launching hopefully soon. He's using the ISS as a test bed for his inflatables. That's a good middle step. So what if you cheat? What if you build your hotel on ISS, so to speak? What if you let Bob launch one of his larger inflatables and see how it goes? Maybe that's the way that we make it happen.
Yeah,
Yeah.
that sounds fantastic.
Yeah. Okay. Sign me up. Okay.
Me too. Well, it depends on how much it costs, of course, because all these economics that we get bogged down with here on Earth, that's a big question mark in space, of course. People have trouble making the economics work. And a lot of that is just simply, again, the fact that we haven't done it yet. And we have not reached the point where people can generate their own ideas and their own opportunities and let them explode. We're just not there yet.
So how big a problem is SpaceX is launching all kinds of little lunchbox-sized satellites into space to give us internet connections on Earth, and Samsung is about to do the same thing, along with Amazon has one of their companies doing that, and several more. And then we run into the issue of space junk and all kinds of other issues. I know space is really big, but at what point does it get to be pretty dangerous up there?
Yeah, I think we've already reached that point where in low Earth orbit, it already is a little bit of a dangerous place. And the problem is not so much that space is big or not. You know, of course it is very big. Even low Earth orbit is huge in terms of volume. It's more a problem of orbits and speeds, because to get things up there, you have to get them going very fast. And that means that anything that falls off, little paint flecks even, they're going to be traveling very fast, and it's basically a ballistics problem. You know, that energy, if it hits something, it's going to be a bad day in space. So yes, orbit will be a huge problem. I believe Elon Musk has put some effort into this, and he has some deorbiting strategies in mind for when his spacecraft reaches the end of their life. I am not as up on that as I probably should be, because it's a very interesting question and a very important one. Especially as you mentioned, there are other companies that are getting into this. Low Earth orbit is about to get a lot more crowded than it is right now. So yes, big problem. Another part of this problem is for the astronomy community. And I'm sure you've heard a lot about that, and your listeners have heard a lot about that. Astronomers are pretty worried right now that we are kind of contaminating the sky for observations of planets and stars and everything. And it's a good point. We need to take more steps to protect our astronomy community. Of course, I'm very biased there because I'm in the astronomy community. But I think most people would agree. The night sky is a precious resource, and it helps us in a lot of ways too, if you think of in terms of that inspirational element. We were talking about edutainment before. All the kids looking up there at the night sky, is it a good thing or a bad thing if they see 50 streaks going overhead from these satellites? You know, maybe some of them that might be kind of cool. Maybe that will be a little inspirational. Say, oh, look at what we did. We put that there. But you're losing a lot too.
Yeah, well, we'll have to be looking through the fleets of drones that are flying overhead anyway. So
that's a good point. It's not just low Earth orbit that's getting crowded.
It's all crowded. All the air is getting crowded.
Yeah, it will be. Yeah.
Well, Brian, that's just about the hour mark. We really appreciate you taking the time to educate us on these topics. This is all fascinating stuff, and you're a excellent tour guide for it all. So we really appreciate that, and wish you all the best.
Well, it has been a lot of fun, and yes, we really just scratched the surface. So it's exciting to think of the possibilities.
Absolutely. Yeah, we'll have to have you back on sometime.
That would be great. Love to do it.
All right. Thanks, Brian.
Okay. Thank you both.